Hi, in today's video we're going to take a Guillows Arrow model airplane kit, build it, add the ParkZone electronics, and have a radio-controlled Guillows airplane. Let's get it. Okay, let's take a look at the kit of the Guillows Arrow. And this is part of their junior contest series of airplanes. It's different than the normal Guillows airplanes that are typically scale aircraft. The scale aircraft look great, but when you build a Messerschmitt 109 or Cessna 152 or whatever, you're limited by the scale outline to what you can do to make it a better flying model. These contest series look a little bit unusual, but they fly great because they're built to fly properly. So this will be a very good candidate for a radio control model aircraft. Also, we'll go over some of the things that I think about as I build this to modify it for radio control flight. So this is a great first attempt to take a Guillows kit, make it into radio control. You'll learn a lot of lessons on building, covering, flying, etc. If you want to tackle one of the more challenging scale types, you can. One other thing to notice on these line of kits is a build by number kit. You'll see on the plans it's a very detailed step-by-step process to build it. If you're new to building model aircraft, this is a great starter kit for it. Literally hold your hand and take you through the building process step by step. Notice also the Guillows kits have been around for years. The first Guillows kits was in the late 1920s. They've rejuvenated their product line with die-cut balsa, and the quality of the wood is much better than it was in the past. It's lightweight, it's die cut, and it just builds a better flying model airplane. Okay, so let's take a look at the inside of the box. We have a very complete set of plans. We'll look at this in more detail after we unbox the kit. There's a propeller, nice big propeller for rubber powered flight. Set of decals. I think those will go well onto the model. These are the vacuum formed plastic parts for this airplane. You'll see a pilot bust, front and back, spinner, and the louvers for the exhaust. This is pretty cheap vacuum formed plastic. The pilot is just about worthless. I don't see much use for that. The louvers I can make out of balsa wood. The spinner, we'll take a look at that. Again, for electric powered models, the motors don't spin that fast. I may make that out of balsa, we'll see. Here's some of the balsa right along here. Some spar materials, and again, it's lightweight, feels like good quality balsa. These are some of the stringers, again, not super well cut, but it's fairly lightweight balsa, and I think this will work out okay for the models. Rubber bands, this is designed as a rubber band free flight model. We're not going to be using that. Kind of heavy hardwood wheels. We'll use lighter weight wheels. Some buttons for the rubber band and clay for balancing the model. Here are the die cut ribs here. Again, it's a pretty basic model, but this is good lightweight balsa. Feeling pretty good about that. Some plastic and some tissue paper. We will be covering our model with heat shrink plastic covering. We will not be using this tissue paper, but back when these kits were designed, tissue paper and dope is what people use, but we'll be using lightweight covering. Okay, so let's take a look at the plans for the Guillows Arrow. This is one of the most complete set of plans you're going to see. There's a front and a back side. So let's just start at the beginning. You notice these are junior contest series, so the idea is somebody who's very new to building model aircraft. There's a very nice picture of the completed frame. That's great. Notice with letters A, B, C, it just takes you step by step everything on how to build the aircraft, to include isometric views of what's laid down. You'll build directly over this for the stabilizer and rudder. Here's the wing layout, the fuselage. Everything's really good. So the other side is to build it. This is for completing it. The fuselage frame here, all the cross members, the side view. This is covering the tissue, don't have to worry about that too much. Adding the plastic parts. If you want to modify it for a gas engine, which prior to electric engines, that's what you had to have, everything's here. So Some things that I'm looking at for this airplane is I always like to take a moment to study the building. There's nothing really unusual or special about this. However, I'd like to touch upon a few things that go through my mind for radar control flight. First of all, it's a free flight model, so there's no plan or instructions on the plan for an elevator or a rudder. We're going to have to build an elevator or a rudder. So I'll probably just draw this line here for the elevator. I'll make a full span elevator, and I'll have to do some thinking about the installation of that elevator such that it doesn't interfere with the movement of the rudder. So I know I have to do that. More details later on. No need for an ailerons, because this will be a 3-channel model with throttle, rudder, and elevator. The fuselage is really quite simple and thin. What I will do, this is the front side of the fuselage. I will probably make this entire front 1/16 inch sheet balsa. I think that'll provide enough strength and mounting for the engine's landing gear. The other thing I'll do is we're going to take a look. This is the ParkZone electronics. I just kind of literally put those over the model side to see where they go, to see how they fit. And one thing to keep in mind is this is a fairly long nose section for the model. We can't have the electronics too far back. We have to have enough length to connect the motor or something like that. But I think we'll be able to do a little bit of trimming and adjusting to get this motor. I may have to trim the plastic here a little bit. We'll give that closer thought once we get closer to that portion of the build. So those are the main things that go through my mind initially as we go ahead. And we're going to do two things with the model. We're going to build the Guillows arrow just per the instructions, but then we're going to always be thinking ahead to what we need to do to modify it for radar control flight. These microelectronics just simply didn't exist when the arrow was designed. There's plenty of room to install the electronics. That's part of the fun. By tackling this fairly easy, well-flying project for the radar control, there'll be a lot of lessons learned that after this model, you want to build your Messerschmitt fighter, P-51, whatever other scale Guillows model you have, you'll have a lot more experience of thinking about these things for that model. Let's talk a little bit about the ParkZone electronics. It'll be the heart of controlling our Guillows model airplane. These are the ParkZone electronics. It's 3 channels, receiver, electronic speed control, and servos with a motor. And there's other videos on this that give more details. This is available from Horizon Hobby. We go ahead and we plug in the battery. Notice a steady light. That means that it is connected. And there's the elevator, rudder, and I'll hold the motor, and that's the propeller. Let's take a little bit closer look at the receiver here. Get my hand out of the way. This is the light that says that it's on. This is the plug for the motor. This is the antenna. Make sure you have that. It's a fragile item. It might break off. And these are the 2 linear servos. Let me move those a little bit here. There's the elevator, and there's the rudder, how it turns. Note also that this little guy has a front and a back. So the gears right here are the front of the unit because you're going to connect your control wires to this output arm here, so it goes back to the elevator and rudder. If you had this way, the control arms would have to go through the gears. It wouldn't work. So the important thing is to remember that the motor plug is towards the rear, and that is your servos right there. Note also on the back of the circuit board, the electronics are exposed. There's nothing protecting them. When I mount this on the airplane, more details as I do that, I put a little thin piece of foam behind that to make sure that it's soft and it minimizes any damage to the electronics in the aircraft itself. Now, to power it down, we reverse what we did. We want to make sure that this receiver always sees the signal from the transmitter. So we unplug this first, then we turn off the transmitter, and everything stays binded. We're starting construction of the wing. You can see the outline of the balsa is put down first. These are just directly from the part kits. The bottom 1/16 inch spar is in place, and the ribs for the right half are glued in place. We've now completed the wing of the arrow, so let's take a look at that on the building board. So per the directions, it's built flat on the building board. Obviously, you can see the balsa leading and trailing edges. The ribs that are die cut came out very good. The spar is a 1/16 inch balsa from the kit. And the one important thing is you'll notice that here at the middle and over here where there's going to be the polyhedral for the wing, these spars are not glued into place. We'll prop them up with a proper distance, which again is listed on the plan, glue them into place, and that will complete the wing. This is the detail of the 1.5 inch jig used to prop up the wing tips for the polyhedral on both sides. Once that is done, the same jig is used to prop up the inner two halves of the wing, with the other side being pinned flat to the drawing board. This is the completed wing, just glue with the top spars hold everything in place along with the center spars. We're going to flip the wing upside down here. You'll see the polyhedral a little bit closer. Note also the 1/32 inch plywood at the center section for increased strength. We're starting on the stabilizer now. The ribs from the kit, a 1/16 inch balsa spar for the trailing edge of the stabilizer. Just have to trim the ribs to fit into place with a 1/16 inch spar on top. Note the next step is we're going to have to add another 1/16 inch piece of balsa for the leading edge of the elevator. That's shown here. It's angled slightly to allow the elevator to go down. Note also, not on the plans, you'll have to add a 1/16 inch balsa spar to give some strength to the elevator. Here the elevator half is separated from the stabilizer, all set for final sanding and finishing. A look at the fuselage. I added 1/16 inch balsa to the front, to the regular frame, 3/16 inch balsa for the fuselage members, quite a bit bigger than on the plans, but needed for the strength of this powered RC model. About halfway through the construction of the Arrow, a Guillows free flight model converted to radio control. As a reminder, this is the Arrow, what we're going to do. Now, we're certainly not going to use a green and orange paint scheme, but it should look something like this. So, I'm very happy so far with the way everything's going. With these conversions, you're designing the model for radio controlled items as you're building it. So I always like to take a moment to think before I do everything, where I'm going to put equipment, just any changes I might make, modifications, and I'd like to go through some of those right now. So let's talk about the fuselage right now. This is the fuselage so far. What I did on this is this interior framework here is from the kit. You can see the A1 and A2 parts. I put on the outside 1/32 inch balsa on both sides just to make it a little bit stiffer and stronger. That's necessary for the motor. It has very little weight. That's fine there. The standard former here with the cross braces that are on the plan. These members here are a little bit thicker at 3/16 of an inch. I think that'll add more strength. Same for the cross members. Standard tops here. On the back for the stabilizer mount, I added these side pieces. I think that's worthwhile. And notice I had to cut down the back for the elevator, which we'll talk about here in a moment. The final thing I want to show you is the nose section on the plane. This is the motor that we'll be using. I clipped off the lower and upper plastic connectors for the foam model. You need to keep this housing where it is. This little dab of glue is at the factory to install the motor, and this housing is a connector for the geared part for the propeller. So this has to stay in place. But these two little arms or wings, whatever you want to call them, I cut out these cutouts into the fuselage nose, and you can see how well that will just go into place once I epoxy it in. So that's a very nice installation for the motor. And also the brick will fit in very well into the fuselage here. It's just about the right width, so I'm happy about that. I think I'm going to keep large portions of this open just for the connector rods and things of that nature. Taking a look at the horizontal tail. As I mentioned in the beginning, I had to make an elevator. This is the elevator right here. What I did was use the ribs, just cut them off at the about halfway, and installed the scrap balsa facing here. The same facing is here, but if you look on the side, it's angled in. The reason that is there is for the down elevator. You can see with tape hinges on the top, this is down elevator and up elevator. You can go up and down. This is important because when it goes on the back here, notice how the down elevator can go down. That's why this is cut out right here. The wing is complete. That went nicely. Just per the plans, there's 2 dihedral brakes, one in the middle and then the 2 on the tips. Glue holds everything in place. Nice flat wing. And the one thing that I did, that I mentioned in the opening video, 1/32 inch plywood here, here, just to keep it strong, connected in the middle. I think that's a good thing for the RC model. The final thing, or 2 things we'll talk about, is the landing gear and the rudder. I've not yet made the rudder. This is the rudder on the plan. They do have an outline for it with the balsa. I think what I'm going to do is just make it a solid 1/16 inch sheet with plenty of room for the rudder on the fin, and then a cutout here so the elevator can go up, not interfere on that. And finally, the landing gear. You notice the rubber propeller is much bigger because of the nature of the rubber-powered free flight. That's why this landing gear is so high. You have to have ground clearance for this large propeller. Because this propeller is much smaller, I can have a shorter landing gear, and so I'm going to experiment on where to put that. Note that the center of gravity is right here, so the landing gear will have to be in front of the center of gravity. I've got a lot of options where to place that. So that's kind of what's going through my mind so far with construction. I'm very happy with it so far. I think the weight targets are being met, and look forward to further construction work. We're now complete with building the frame, and we're ready to cover. So let's look at some things that happened with building the frame. This is the elevator and stabilizer. The one thing I wanted to point out is I put a few 1/16 inch balsa here to stabilize where I glue it on to the back of the fuselage, and this is a little bit of a balsa buildup for the control horn mounting on the elevator. So we have some place to put the control horn. As I mentioned, here are the fin and rudder. I decided to make this out of 3/32 inch balsa. 1/16 inch was just a little bit too low, and this cutout allows for the elevator to go up with plenty of rudder for what we need on the airplane. I think the fuselage came out pretty nice. Here's the nose section. I put some soft balsa for the top here. That adds a minimum amount of weight. We probably need some nose weight anyhow, and it really stiffens up the front part of the structure as opposed to the stringers here. You can see how the motor glued in very nicely. I just put epoxy into those slots there with a little plywood reinforcing, so I'm completely satisfied with the motor. The brick for the electronics fit in. I just put a dab of epoxy in the corners to hold it in place. That'll be fine. Notice the motor wire connection. This is the battery with the Velcro for the battery right here. The wing will be mounted here, the fuselage, some balsa for the cockpit. Then in the back, as I mentioned earlier, the cutout for the elevator, and then just some side mounts for some stability where the stabilizer goes on. Finally, the wing, as we saw it before, the changes I did make was rubber bands are going to come over the front of the wing to hold it on. So I put, this will just be plastic covering. I just put some reinforcement formers here, 3/32 inch balsa to make that just a little bit stronger. Also, to keep the rubber bands from chewing into the wing, 1/32 inch plywood, I glued that here to give it a little bit of strength. And then just a little bit of surface area under the wing for the mounting on the fuselage. And that all goes right in here. So, I think we're making good progress. The next step will be to cover it and then put everything together, put on the landing gear, and go ahead and give it a test flight. We're making good progress on the arrow, so this is a great time to discuss where we are. The wing has been covered. It's a lightweight iron-on plastic covering. Be careful not to shrink it too much, but the covering, once it's shrunk evenly on both sides with heat, actually strengthens the whole structure. It's just a nice little wing right here. Now, this is going to be important on where we are with the fuselage construction. You notice the tail feathers are installed and I'm covered back here. The reason is one of the trickiest parts of these ParkZone installations is getting all the control rods hooked up completely and correctly to the tail surfaces. So what I would recommend to you on these types of models is install the tail surfaces, look at where your control rods are going to run, and then build it and install that before you cover the fuselage. and you'll see that there are some plastic guide tubes glued to cross struts along the way. There's one here, here, back here to keep from flexing in the music wire. And then it's just a Z-bend that goes into the ParkZone electronics at the control unit itself. Now the one thing I want to cover is this section right here, which is an adjustment for the music wire to make sure you get the right length from here down to here. And a great technique is what you see here. We'll take a picture against the board. Here's very thin music wire with a Z bend here that goes into the control unit. Another Z bend that goes into the control rod and back, and some heat shrink tubing. We simply put the heat shrink tubing on the music wire, and notice how it overlaps. So when we install it, we can adjust the length so that the elevators and rudders are neutral. And then once the wire is at the correct length, take a heat gun, heat shrink it, little dab of epoxy on each end, and that's a perfect way to get the correct length for this very long control run. And as you can see, this is the the heat shrink tubing right here, and then the control runs over here. We've installed the control rods. Let's go ahead and power up the system to see that everything works okay. The DX6 is on. We have the arrow selected. Remember, we want the model selected before we plug it in with these ParkZone equipment to keep things all correctly bound up. The batteries do have a polarity, red dot down. And we have just a little bit of Velcro inside there, so you can see the battery is held. And what we'll do, we'll take a look at the tail here. Elevator up, down, left, right. And then the throttle works as well. So everything's hitched up correctly with the control rods and the transmitter. We'll now cover the fuselage, install the wing hold down dowels, and go for test flight. I finished building the arrow. You can see it's here with the wing installed, and I'd like to go through a few thoughts on this before we go out for the first flight. I've made some notes here. Okay, the first thing is the center of gravity location. It is vital for any airplane from the 747 to the Arrow to have the correct center of gravity. So if you look on the plans right here, it's really odd. The center, it says the point of balance. They really mean center of gravity. It's very close to the edge of the wing. Normally, you're about a third of the way in from the leading edge. Why, I do not know, but that is the center of gravity right there. And so that's where it balances out. Again, I can put my fingers under about that point. You can see that it balances correctly. To do that, if you look carefully underneath the motor, I had to epoxy in 2 washers to get it to the correct center of gravity. So no problem. It's a small amount of weight. The model weighs 2.5 ounces, which is well within its target weight, but absolutely, absolutely make sure any airplane you fly balances at its center of gravity. The other thing that I did was I kept the bottom open. You can see the covering goes up to here. The battery Velcro is right here. The electronics, the motor. It's okay to keep this open. I have access, I can see everything. You can cover it if you want to, but just for this kind of prototype test one, I think it's fine to leave it uncovered like that. The landing gear. So this is the landing gear, and if you look inside, I just did a U shape that fits into channels I cut on the side, epoxied it in at an angle. It's simple, it doesn't get in the way of anything. I just took a guesstimate at the size of the music wire. I think it came out about right. These wheels weigh nothing, and then I just did a little upturn of the music wire to hold it in place. Plenty of strength for a model of this size. The final 2 items to remark on is you'll notice for the elevator, I had a continuous elevator, which meant that I had to build in this space here for the elevator to go up and down. I think it looks kind of silly. If I build another one of these, which I might do, I'll make a V in the elevator, so this can be straight on, and just the elevator won't interfere with that. I think it'll look a little bit better. Notice that I have a fairly large rudder for the 3-channel models. I think it's always good to have a little bit extra rudder, and I think that'll be okay. The final thing I want to mention is on the top of the nose located here. This is soft balsa. It's a block that I carved to shape. Adds very little weight, but boy, it really strengthens up everything around the nose section. And it turns out that that was a great place to glue the washers for the center of gravity. So that's the completed model. I think it's all set to fly, so let's go ahead and see how it goes. Just completed the maiden flight of the Arrow. It could not have gone any better. It's one of the best flying models I've made. It just literally flew out of my wife's hands on the flight. You saw the landings, the takeoffs. It just has an absolutely solid feel, no vices. Looking forward to future flights with this guy. So I'm back from our first flight with the Arrow, and I haven't had a model fly much better than this. It just literally, my wife did a hand launch. It flew out of her hands. It just, the moment that thing left her hands, I knew this was going to be a good flying model. There's plenty of rudder area. The turns were good, as you can see in the video, and it just behaved well. It was just a smooth, consistent, easy flyer. The second flight I did takeoffs from the ground, it came out just fine. Now, comparing it to the Lancer, which you can see in another video I have, it's a bigger model than the Lancer. The wing is bigger. It's about a 4-inch greater wingspan, much wider wing, a little bit bigger fuselage. The size and the weight, the Lancer flies fine. This really, really flies well. So I think the RC conversion was a complete success. What I do with these ones is, the first one's kind of what I call a rough prototype, so I'm not going to bother filling in the center section, but it's very easy to add windshields, pilots, canopies. Now that you know that it's going to fly well, it is absolutely suitable for doing a more advanced design. And I highly recommend the Arrow for an RC conversion for Guillows. With the ParkZone equipment, it can be done, flies great. Thanks for watching, and we'll see you next time.